Hi, welcome back to my Learn Easy Maths channel. Friends, how are you? Hope you are all in well conditions. With this hope, today once again I am before you with my new topic and with my new discussion. As you know that in my previous discussion, I discussed about you the algebraic identities based on the squares. That is a plus b whole square, a minus b whole square, and a plus b into a minus b is equal to a square minus b square. Actually, I have taken the form of that a plus b whole square in a way that its terms LHS is equal to RHS in that format, and in that pattern I have proved it. For example, a plus b whole square is equal to what? A square plus 2ab plus b square. Then if you take only a square plus b square, what it is equated to? When you take a plus b whole square, what it is equated to? Just you pick out and just equate it. 2ab is equal to what? That way I have manipulated the equations LHS to RHS. Now today I would like to just take one more example which I have drawn from the example of a square plus b whole square only, so that after that I will just proceed on to the cubic expansion. The first one is, friends, a plus b whole square is equal to a minus b whole square plus 4ab. This is very, very important. When we solve the problems of the conditional identity, it used to be some years before, not now in our particularly this present syllabus of our 10th standard mathematics. But I feel it, past 10 years back, we had this type of conditional identity problems where it was very useful at then. Now it is also now it is useful. It is good for us if you interact with the updated knowledge every day. A plus b whole square is equal to a minus b whole square plus 4ab. This you have to just make understand the children. What is that now? Means this is LHS and this is RHS. I expand this as usually you know that a square plus 2ab plus b square. This is what? LHS. Now it is equated to what? A plus b whole square is equal to a minus b whole square plus 4ab. Then you expand this. I have expanded this. Now you expand this. A square minus 2ab plus b square plus 4ab. Alright. Now this is equal to a square. Here we have minus 2ab and plus 4ab are the like terms. But one is a minus, another is a plus. Minus 2ab plus 4ab. So it is plus 4 is a plus is a greater term and minus is a smaller one. So that's why we take plus 2ab. Isn't it? Minus 2ab plus 4ab is plus 2ab plus b square. Have you proved it or not? RHS. LHS is equal to RHS. What it is? A plus b whole square is equal to a minus b whole square plus 4ab. This is one example. If you just show this one, no, it will be very interesting, because the children are only, they are well acquainted with this common knowledge. A plus b whole square is equal to what? A square plus 2ab plus b square. But we should make aware them and we should make them understand that yes, a plus b whole square can also be written as a minus b whole square plus 4ab. Then you make the reverse of this one. Yes. Here a minus b whole square is equal to a plus b whole square minus 4ab. Okay. But this way you can just prove it. Now you prove this LHS, what it is? A square minus 2ab plus b square. Alright. Now you expand this, write RHS. A square plus 2ab plus b square minus 4ab. When we simplify this, now it is a square plus 2ab minus 4ab is minus 2ab plus b square, where LHS is equal to RHS. So these two formulae, we should make them understand that a plus b whole square is equal to a minus b whole square plus 4ab. A minus b whole square is equal to a plus b whole square minus 4ab. It is plus 4ab and it is minus 4ab. This we should just explain to the children. Now coming to the cubic expansion, cube formula. We have discussed this square formula and now we will discuss the cubic formula. How it will be. Just see that. A plus b whole square we have discussed so far now. We will discuss it. A plus b whole cube. A plus b whole cube. What's a plus b whole cube? It is written as a cube plus 3ab bracket a plus b plus b cube. Okay. This is the expansion. Still we expand and we can just simplify it. Look at the board. Still we can expand and simplify it in a very, very simple and lucid manner. How it is? A cube. Outside the bracket, multiply the terms with the inside the brackets. When you multiply the terms inside the bracket, what do you get? 3. A into a square just b. Okay. Plus 3 a, b into b square plus b cube. Therefore, a plus b whole cube can also be represented and written as a cube plus 3a square b plus 3ab square plus b cube. And one thing you are observing it. In my last video, I told you that whenever we raise the power to the biological terms, whenever you raise the power to the sum of the terms, it gives the expansion one more term than the expansion. For example, see a plus b and its power is raised to 3 times. Here we get 4 terms. 1, 2, 3, 4. Isn't it? In square we got 3 terms. In cube we get 4 terms. In 4 power we get 5 terms. Similarly, in 6 power we get 7 terms. For the 10 powers we get 11 terms. For the 100 powers we get 101 terms. For the n power, as I told you, the basic essence and the basic criteria of binomial theorem, n plus 1 term. Alright. Now this is one. As I told you that this is the expansion of a plus b whole cube. Let's see that in my last video how I have taken that manipulated LHS to the RHS. Here also I am going to do the same. Please watch it. Take a cube and b cube. Or just to take, this is LHS and this is RHS. A cube plus 3a square b plus 3ab square plus b cube is equal to a plus b whole cube. But I want only a cube and b cube. I need this much only. Alright. Then retain it a cube plus b cube to the left side and you just transpose it. A plus b whole cube, and this will be minus 3a square b minus 3ab square. Alright. This is the way. Now we can just get this form also. A cube plus b cube. Now you see that one, a plus b whole cube minus, what is common? 3ab is common to this one. And you get a minus b. Alright. You get what? A minus b. Because a plus b whole cube, from here 3ab, 3ab, 3 out, a out, b out, just from a square, a is there. 3 out, a out, from b square, b out, b is there. Now here what do you get the common to both here? You get the common to both here. I am sorry to say that it is a plus because we have to take minus sign is outside minus common. No. Now the common thing is a plus b. A plus b is taken out from this one and from this one. It is a plus b whole square minus 3ab. Alright. From a plus b whole cube and a plus b, when you take common term as an a plus b, you get here, it remains a plus b whole square and it is minus 3ab. Now on expansion, a plus b is out and here a square plus 2ab plus b square minus 3ab. Alright. This is equal to a plus b into a square plus 2ab minus 3ab. This is a common term. So we get minus ab and it is plus b square. This is the answer for this one. This is the answer for this one. What is a cube plus b cube? It is written as, listen here, a cube plus b cube is equal to a plus b into a square minus ab plus b square, which is our final derivation. But this way we can just find out what is a cube plus b cube, right? Similarly, we will find a minus b whole cube also the same way. Here I am going to write viewers, a minus b whole cube is equal to what? A cube minus 3ab, a minus b minus b cube. Be careful. This is our expansion. When you compare to the positive identity and the negative identity, the powers, the terms, they are all one and the same, only they are different with their signs. Okay, here all signs are minus, here all signs are plus. For a plus b whole cube plus, for a minus b whole cube minus. Now when you look into this one now, see that one. This is a minus b whole cube is equal to a cube minus 3a into a square b minus into minus plus 3ab square and minus b cube. Alright, this is the form. This is the form you have to write it. Now I write like this: a cube minus 3a square b plus 3ab square and minus b cube is equal to a minus b whole cube. But I need only a cube minus b cube. Okay, just how I have taken here a cube plus b cube, here also I am going to take a cube minus b cube. Let's see what happens. A cube minus b cube is equal to a minus b whole cube. Then this will be plus 3a square b. This is minus 3ab square. Alright. Then this is equal to a cube minus b cube is equal to then a minus b whole cube. Then take common, plus 3ab is common. Here it is a and here it is a minus b. Alright. This is equal to a cube minus b cube. A minus b whole cube, a minus b is a common term. When you take a minus b from this one, it will be a minus b whole square plus 3ab. Alright. This is equal to a cube minus b cube is equal to a minus b into, expand it, a square minus 2ab plus b square plus 3ab. This is equal to a cube minus b cube, a cube minus b cube is equal to a minus b. This is a square minus 2ab plus 3ab is just plus ab plus b square. This is the form of a cube minus b cube. I hope you followed it. Okay. But this way we can make interesting, and also we can comprehend the thing very easily, because it is our common trait and psychological feelings that whenever the child comes to know the name of the mathematics, he starts imagining, he starts visualizing, he starts deliberating many more things, as if that mathematics is something, a big rock which cannot be scaled up. So this is completely a myth. We have to just break the myth among the minds of the children, and we should bring more near and near towards mathematics by showing them just what no, learn and play, play and learn. This way that we can just make them understand. I am going to take some example based on this cubic formula. Okay. See. Hello friends, welcome back to my Learn Easy Maths channel. Hi friends, how are you? Hope on the occasion of meeting this video and discussing with you today's discussion of the topic, I find you will be in a very stable and also zealous and passionate condition of your learning this topic. Without further any making more vocabularies and the words, so that it will also make you more confused and it also make me more chaos, I would feel better and I prefer it that let us straightforward we go to the topic any further delay. As you know that we are dealing the videos related to the algebraic identities, and in my previous video we have discussed a plus b whole square identity, isn't it? Alright. Now also in my second video we are discussing now the a plus b whole cube identity, and we have discussed couple of minutes before I have discussed in my video that a plus b whole cube, how it is written, a plus b whole cube. Let me write this algebraic identities. So in this series of algebraic identities, today we are on the discussion of cubic identities. A plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Alright, this is the first identity. The second one is change the sign, a minus b whole cube, a cube minus 3a square b plus 3ab square, and this is minus b cube. This is the second identity. First identity is based on a minus b whole cube. Second identity is based on a plus b whole cube, and the second is a minus b whole cube. Alright. Now what do we do now? Just there is another identity is that a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. The next is a cube minus b cube is equal to a minus b. I am getting sound, please go slow it. A cube minus b cube, a minus b, a square plus ab, and this is a plus b square. Alright, now, and these are the expansion and this derivation and how we just obtained this expansion I explained in my previous video. Alright, now we will see that if we put some values in it, do we get exactly the same and it is applicable on these identities? Yes or no? Let's see that. Let's take 7 plus 4 whole square. We have to just test it that what a plus b whole cube is it hold true and it endorses or not, the expansion is correct or not. 7 plus 4 whole cube, square not whole cube. Substitute is a plus b, where a is equal to 7 and b is equal to 4. A cube, this is 7 whole cube minus 3, a is 7 square and b is 4, and plus 3, alright, plus, and this is plus 3, and what is a is 7 and b is 4 square plus b whole cube is 4 whole cube. What we have done, in place of a and b, we have substituted their respective values. A is 7 and b is 4. A cube plus 3a square b plus 3ab square plus 4 whole cube. Now this is equal to cube it 7, not it is 7 3s are. We have to make aware and should make understand the students to get over from the confusion. They should come out of this confusion that what the power and what the base, they should not make it direct multiplication. They have to expand it. 7 to the power 3 doesn't mean that 7 3s are. 7 to the power 3 means 7 multiplies 7 multiplies 7 3 times. 7 7s are 49. 49 7s are 343. That we have to explain them. 343 plus this is 3, 7 square is 49 and this is 4. This is 3 into 7 and this is 16 and this is 64. The first and last, anyway, I just simplified. 3 whole cube, 7 whole cube is 343, 4 whole cube is 64. Now, see this one, 343. You may simplify this one. 3 4s are 12. 12 into 49. Okay. 12 into 49, 12 9s are how much? 108. It is 10 and 12 4s are 48 plus 10 is what? 48 plus 10 is 58. This is 588. Am I correct? Plus this is 16 7s are 112. Okay. 16 7s are how much it is? 112. 112 into 3 it is 336 plus 64. So these are the simplification that we have simplified here and we expanded. Let's say add all this 3 4 3 5 double 8 3 3 6 and 6 4. As I told you, for cubic expansion, after the expanding the identity with 4 terms. For the square expansion, after expanding we get the 3 terms in the expansion. Right. Now you add all these. 6 plus 4 10 18 11 1 carry. 1 plus 6 7 10 18 and 22 2 carry. 2 carry. Okay. Then it is 1 plus 7 1 plus 6 7 10 18 22 2 carry. All right. Then 2 plus 3 5 5 plus 5 10 10 plus 3 13. So see, check it once. 10 18. This is 21 2. Sorry, it is 1331. 1331. What is 1331? 7 plus 4 whole cube, which is equal to 11 cube. 7 plus 4 whole cube, which is equal to 11 cube. Do we get the same or not? So the same way, if we apply this into a minus b whole cube form, all right, a minus b whole cube form. Let's see, do we get the a minus b whole cube also correct or not? Test it. The next one is a is 7, b is 4 minus 4 whole cube, and you apply the formula. For the first formula a plus b, we applied this one. For the a minus b, we will apply this one. A cube 7 cube, okay, minus 3 7 square into 4 plus 3 into 7 into 4 square, and this is minus 4 whole cube. The formula, we have substituted the respective value, as a is a 7 and b is 4. 7 cube again as it is 343, and this is 3 into 49 into 4 plus 3 into 7 into 16, and this is minus 64, which is equal to 343. And what it is, how much it is? 3 4s are 12, 12 9s are 108, it's 10, and it is 58 minus 588, and this will be 3 7s are 21, then 21 16 ones are 16, 6 1 carry. You just 3 7s are 21. This 21, 16 ones are 16, 6 1 carry, 16 2s are 32, 32 plus 1 it is 33, and this is 64. Here clearly you can see that out of the 4 values you have 2 positive and 2 negative values. So add separately. What are the positive values? Now it is 343 and 336. Add it. 343, 336. Both are positive. And both are negatives. What? 588 minus 64. Add the like terms. It is 9, it is 7, it is 6 plus 679. and it is 12 and it is 15 and it is 652. It is a minus 652, it is plus 679. So plus 679 minus 652. What the answer we get? We get it is plus 27. Yes, obviously 7 minus 4 whole cube, which is equal to 3 cube, which is equal to plus 27. This is the way that we can prove it. You might be surprising to know all this, that why am I doing all this, putting the values? Because these are the theoretical expansion, whatever it may be, whether we take square expansion or we take cubic expansion, until and unless if we just give some values and we solve it by putting the numerical values in these identities, the child may feel little difficult in understanding exact the concept of this theory. Okay, that's the reason that I have just taken the values. Now let's we test two more identities for our this concept. Now here I am going to take different values, not 7 and 4. I'll take this identity. This is a cube plus b cube is equal to a plus b into a square minus ab plus b square. Let's we take the value of a cube b cube is, it is what, 5 whole cube 6 whole cube is equal to. So here in place of a I have taken 5 and in place of b I have taken 6. Now a plus b, 5 plus 6 into a square 5 square minus a into b, 5 into 6 plus b square 6 whole square. Now close the bracket. Alright. Now you take this one, 5 cube, 5 5 is a 25, 25 5 is a 125. 6 cube, 6 6 is a 36, 36 6 is a 216. Okay, this is LHS and RHS. Now you add 6 plus 5, it is 11. Keep it outside now. 25 5 square minus 30 plus 36. This is a RHS. Now keep 11 outside as it is. Now first make the simplification of inside the bracket. 25 plus 36 is how much? It is 61. 61 minus 30, which is equal to, when you add this one, 125 plus 216. Now coming to this side, 125 plus 216 is equal to 11, and inside the bracket this is 25 plus 36 is 61 minus 30, it is equal to what? 31. Alright, this is equal to, then you add 6 plus 5 11, 1 plus 1 plus 2 4, and this is what? This is 2 plus 1 is 3. 6 and 5 11, and 1 plus 1 2, 2 plus 2 4, and 2 plus 1 is 3. This is 11 ones are 11, 1 carry 11 3s are 33, 33 plus 1 34. So 341 is equal to 341. Therefore LHS is equal to RHS. This is what we proved, that the identity a cube plus b cube is equal to a plus b into a square minus ab plus b square. Similarly we can prove the next identity a cube minus b cube. I hope you are all following, friends, viewers and my colleagues and those whosoever may be watching, and it is a sincere appeal for all of you, just please subscribe my channel and you watch it from first to the last, and you spread and you circulate and you just make viral this video among all your learners, so that they can get an idea of cubic and square expansions. Next it is a cube minus b cube is equal to a minus b, a square plus ab plus b square. What the value we have taken last time? This is 6 cube minus 5 whole cube, which is equal to 6 minus 5. This is 6 square plus 6 into 5 plus 6 into 5 plus 5 whole square. Close the bracket. Now 6 cube, it is equal to what? 216. 5 cube, it is 125. 6 minus 5 is very simple, it is 1. Keep outside as it is. 6 square is 36 and 6 5s are 30, and this is what 5, this is 6 square is 36, 6 5s are 30, and now it is 25. Alright. Now see that one. What is the difference between 216 and 125? 6 minus 5 is 1. 11 minus 2 is 9. It is equal to 92. Alright. What it is? 6 minus 5 is 1. 11 minus 2 is 9. So 92. 92 we have this one. Alright. Now here 1 minute. This is 6 cube is 6 is the 216, 125. 216 minus 125, it is 1, it is 9. Alright. This way we can just get it. Alright. This is equal to what? 6 minus 5 is 1, which is equal to, now 1 outside. Then you add all this. What do you get now? 36 plus 30 is 66. 66 plus 25, which is equal to what? 91. 36 plus 30 is 66, and 66 plus 25, again you get 91. LHS is 91, RHS is 91. By this way, today we have discussed about the cubic identities a plus b whole cube, a minus b whole cube, a cube plus b cube, and a cube minus b cube. I hope you enjoyed in watching this video. If your comments are just being commented, if your comments are being forwarded, then I will take it as a constructive way, and I will still try to improve more. Please do not forget to subscribe, and do not forget to share, and do not forget to watch till the end. With this, I am going to take a leave. Bye bye. Thank you.